taking your time and joining the ninth episode of AWS Mainframe Modernization Broadcasting Channel. Thank you for your active participation since beginning of this year, and we have been adding new sessions. So please stay tuned for the next set of sessions, which are going to be added post the New York Summit, which is happening on June 17th. So in our today's webinar, we are going to discuss breaking data silos, moving mainframe data to Snowflake for enterprise-wide analytics. And the webinar is primarily going to be delivered by our ISV partner Treehouse. So Treehouse has been serving enterprise customers close to 4 decades now, providing solutions for real-time data replication between variety of mainframe and non-mainframe data sources. I'm Sunil Divila, and I'm a worldwide mainframe modernization solutions architect based out of Atlanta, Georgia. And along with me, I have Ellie from Treehouse. So Ellie, would you like to introduce yourself?
Yes, hi everyone. My name is Ellie Savova, and I work at Treehouse Software, focusing on developing cloud-native SaaS solutions as a cloud solutions architect for large enterprise data migrations. And I work very closely with our customers throughout their product implementations.
Wonderful, thank you, Ellie. As we keep delivering the presentation, so please feel free to drop your questions in the Q&A window over here. So as the presentation is going on, we are going to pick, one of us are going to pick those questions and respond, or we will discuss those Q&A at end of the last hour. Okay. Let's review the problem statement. Basically, what's the enterprises are facing today. So we all know mainframe data has remained siloed for decades, largely inaccessible to the broader enterprise across the organization. And because of that barrier, it has prevented organizations from leveraging the data for analytics and AI. And as a result, businesses are prioritizing data modernization because of that barrier to centralize their data in the cloud, which helps in unlocking enterprise-wide visibility, analytics, and innovation. So let's see what exactly the data modernization means. So the definition itself says like it's a process of transforming how your organization stores, uh, retrieve, move, and consume the data to support your modern cloud initiatives. Uh, so with this, I will hand over the presentation to Ellie, who is going to demonstrate how data modernization is possible using the Trio solution with a demo as well. So over to you, Ellie.
Thank you so much, Sunil. Now let's shift from a conceptual data modernization to an actual mainframe modernization journey. Let's look at our agenda for the day. We'll begin with a brief introduction of Treehouse Software, and then we'll dive into today's customer case study right away. We'll look at the challenges that the enterprise faced, their modernization strategy, and the solution we were able to provide for them. From there, we'll walk through how the solution works, how data moves from the mainframe into the target platform, its value, and how the architecture is deployed all on AWS. Finally, we'll review the business outcomes and finish up with a demo. As Sunil mentioned, please feel free to submit any questions as you go. My colleagues will be answering most of them in the chat. We'll also leave some more time at the end for Q&A to address everything in more detail. With that, let me start by introducing Treehouse. So Treehouse has been helping customers move and integrate data since 1982. We started out by developing mainframe tools, and then in the mid-90s, Treehouse further evolved into mainframe to RDBMS replication. Then by the early 2000s, we had expanded into cloud data replication. That evolution brings us to where we are today, supporting both mainframe and non-mainframe data sources across modern cloud environments. We work with organizations across a very wide range of industries, including banking, finance, telecommunications. We have a good presence in the government sector as well, transportation, and many others. One thing we've learned over the years is that regardless of the industry, enterprises eventually face the similar challenge, which is critical business data becomes siloed across legacy systems, just as Sunil mentioned, making it difficult to use effectively. For our customer in question, though, this data silos was what ultimately led them to begin their modernization journey with us. Now let's meet the customer. Who is this we're going to be looking at? The organization we'll be discussing is a large auto manufacturer with critical business processes all running on 3 mainframe systems. So they were looking at AWS, vSAM, and DB2. Over time, these systems became home to a significant amount of business critical information, supporting their daily operations across their entire enterprise. At the same time, the auto manufacturer had already invested in Snowflake as its strategic target and wanted a way to bring that mainframe data, all three sources, into their broader ecosystem. The goal was very straightforward: make this mainframe data more centrally accessible to the business and provide a foundation for future initiatives. On paper, this sounded simple enough, but as we'll see next, achieving this goal proved to be much more challenging than they had originally expected. The auto manufacturer had already tried solving the problem on their own. They faced that build versus buy conundrum and, like, let's see if we can build it before we try to buy something. They built mechanisms to move some bits of mainframe data into Snowflake, but the approach just never scaled and it wasn't up to the level that they needed for their large enterprise. A small trickle of data would eventually make its way across to their target platform of Snowflake, but it took 2 3 days, required hours of manual effort every single time reformatting the data. It just wasn't a reliable enough method for this enterprise. The business users still had to go back to the mainframe whenever they needed the most current information. They didn't know if what they had coming in was current. It just wasn't complete. The reporting teams, they were working with stale data, and the analytics team struggled to get the complete view of the business because that data delay from the different systems, it wasn't something workable. Um, After investing significant time and effort into their own mini modernization project, it became very clear that they needed a scalable, automated way to continuously move data from these three: AWS, vSAM, and DB2 sources to Snowflake. Now, to understand the gap they were trying to close, let's take a look at their broader migration initiative, because it's not just these three databases. The organization was already consolidating data from many different systems across the business into Snowflake. Their Oracle databases were getting into Snowflake, SAP data, factory, IoT devices, everything was now in Snowflake, but the missing pieces were those from the mainframe. They're really hard to get to. Without their AWS, vSAM, and DB2, they could never achieve the complete data consolidation initiative they were looking for in Snowflake. But why go to Snowflake in the first place? The reason Snowflake became such an important part of this initiative was because they had already picked that as the company's strategic platform for the future. Business users wanted a modern, easy to use, centralized console where they could quickly combine the findings across all the other systems into one. Great idea, right? They sought to eliminate having to go to 10 different places and manage 10 different logins for each system. A lot of us know how that can be. The data modelers also needed everything in Snowflake. They had built all these trend analyses, formulas, and queries, but then they were stuck piecing the data together themselves, which they spent more time on than actually doing analytics. And how is that efficient? Oh, and the leadership, looking ahead at how machine learning models and AI were becoming way more and more current and practical, realizing that those tools were powerless until they were reliably connected to data sources all in one place, namely Snowflake, that provided all these capabilities. The challenge was establishing a reliable way to continuously move data from AWS, vSAM, and DB2 into Snowflake. And that's where we come in with Treehouse and our TDT offering, which was able to continuously move data from the three: AWS, vSAM, and DB2 sources on the mainframe into Snowflake at scale. Now, TDT provides both bulk load and change data capture capabilities out of the box, which meant they could not only bring existing mainframe data into Snowflake, but they could also continuously capture the changes in near real time, which was the biggest thing for our auto manufacturer. Instead of spending months and years building infrastructure trying to, they could focus more energy and time just consuming the data, working with it. So TDT went in nicely. So what is TDT? This tongue twister. TDT is short for the Treehouse Data Flow Toolkit. It's an AWS native microservices application designed specifically for moving data into modern analytics platforms. TDT supports targets such as Snowflake, Amazon Athena, Amazon Redshift, and others. Most importantly, it is delivered as a pre-architected and pre-configured solution. So what that means is customers don't need to build any part of the framework themselves. The automatic creation of the framework in AWS is part of the solution. But moving the data from a mainframe into an analytics platform is much more complicated than just simply moving records from one location to another. And to understand why it's so complicated, we need to look at the differences between the source system and the target platform. So Database, vSAM, and DB2 are OLTP environments. OLTP is online transactional processing systems. Their job is to support day-to-day business operations by continuously processing transactions that comprise of your general inserts, updates, and deletes. Transactional. Now, Snowflake, on the other hand, is an OLAP environment, online analytical processing. Its purpose is very different. Snowflake is designed for reporting and large-scale analytics across massive data sets. Under the hood, Snowflake is a distributed processing platform optimized for analytical workloads. So it can do way more than your traditional transactional databases. Moving from an OLTP environment to an OLAP environment, so transactional to analytics, is not the same as transferring from one transactional database to another. It's not like you're moving from Oracle to Microsoft SQL, for example. The data must be delivered in a way that analytics users and the platform can efficiently consume and leverage it at scale. And there are transformations that go into that. And that's the challenge the customer faced and why they weren't successful. And it's exactly the problem that TDT was designed to solve. TDT bridges the gap between the transactional and the analytic system, continuously moving from the mainframe into Snowflake in a format optimized for that analytics. Once the data reaches Snowflake, TDT also provides a number of capabilities that make the data immediately usable across teams. TDT doesn't just move the data, it also creates and manages the Snowflake resources required to consume that data effectively. Before data can be loaded into Snowflake, before you can do anything, someone has to create the target proprietary resources. And those would be the schemas, the stages, the file formats. These are all proprietary to Snowflake. But then we have the tables and the views, those empty tables and views that you need to then populate once you do your loads. Thankfully, TDT automates this entire part of the process. Once those resources are in place, then TDT performs the initial bulk load and then continuously processes CDC events as changes occur on the mainframe. The two most important resources created by TDT, I'd say, are the delta tables and the views. It's what we're going to be physically looking at the most. Let's start with the delta tables. So every single insert, update, delete that's captured from the mainframe is accumulated in these delta tables. Rather than only maintaining the latest version of a record, TDT continuously preserves the history of changes here over time. So these delta tables are designed to, you set them up at the beginning of your implementation and you keep them forever and ever. They hold all of that history. And at Treehouse, we often say history is gold because over time, these delta tables become a growing analytical asset because they're essentially a log of all the transactions that happened on the mainframe since you set up your pipeline. Your analytics teams typically consume exactly from these delta tables because they want access to the complete history of how the business evolved over time. Analytics is all about time. The earlier you start capturing it, the more valuable it is. On top of these delta tables, however, TDT automatically creates views. This is a functionality in Snowflake. You can create a view on top of a table. These views represent the current snapshot of the business and are continually refreshed as the changes arrive from the mainframe. So the delta table will hold everything. The view will just show you the current snapshot. Now, business users, different from your analytics teams, right? Your business users generally don't really care about history and analytics. They simply want the current state of the business to do their reporting, to do their daily business initiatives. That's why they typically just consume the views. TDT just provides both audiences with exactly what they need from the same data pipeline. You don't have to create multiple pipelines. It's an all-in-one solution. Current state business views for reporting, and then you have the complete historical data for analytics. And that's one of the reasons this solution has been so successful for our auto manufacturer in question. In Snowflake, they have an even greater flexibility and they've defined even more views on top of these views that we see here. But that is just something to play around with once you get the product and you fit it to your needs. But these are the basic ones they utilize the most. Now let's look at what the architecture actually looks like of TDT. One important thing to note is that TDT doesn't go directly after the mainframe by itself. So instead, it works alongside a mainframe data replication tool that captures the changes happening in the source mainframe. And then customers can use different tools here. So you can have any replication tool. In this implementation, the auto manufacturer used Rocket's RDRS tool, but you can substitute this with anything that you already have, right? The mainframe replication tool captures the changes occurring on the mainframe and publishes them to a data streaming platform. This is also a substitutable component. They chose Amazon MSK Kafka as their streaming platform, but it can be, yeah, it can be anything. It could be Amazon Kinesis data streams, for example, or any other flavor of Kafka. There are so many. Now, the RDRS MSK Kafka combination for our customer was an easy go-to because Treehouse partners with Rocket. Thus, RDRS setup can be fully automated along with the build of the TDT infrastructure. Creating the MSK Kafka topic just becomes another piece that gets automatically spun up by TDT. And of course, if an organization wishes to substitute these components, plugging them in is very easy. Now, TDT processing kicks in right after mainframe to streaming platform connection is in place. So as soon as the data arrives in this Kafka topic, and all this is near real time or real time, TDT then takes it the rest of the way into Snowflake with a bulk load and or CDC. Now, everything you see inside this AWS box is what TDT is comprised of. So TDT, you're like, well, what is it? It's a collection, it's built on AWS. So it's a collection of AWS resources all configured. At the core of the solution, it is a collection mostly of AWS Lambda functions that perform the processing required throughout the data pipeline. TDT is built as a serverless microservices application, which allows different parts of the framework to scale independently as work demands change. Part of the reason it's built on AWS, leverage the cloud. You'll also notice Lambda layers here. Treehouse uses Lambda layers to package and manage code across the platform, making it inherently secure. Amazon S3 serves as both the data storage and the working storage layer throughout the transfer process. AWS Secrets Manager secures and stores the credentials and connection information, so you don't have anything exposed. Then you have EventBridge, which is used to orchestrate the activities across the framework, while Athena provides operational visibility and monitoring capabilities. Together, all these managed AWS services allow TDT to remain highly scalable, available, keeping things very hands-off for the customer. The customer only has to, they can only tweak the controls. It's meant to be like a whole SaaS offering. And because everything is deployed directly in the AWS environment of the customer, they get to maintain ownership of the infrastructure, their security controls, and the data itself. So no data is leaving your AWS environment. Everything is staying in your account. The setup of all these components, and there are many more components listed here, I've just shown you a couple, is done using what's called a CloudFormation template. When you run a CloudFormation template in AWS, it automatically installs and configures the entire TDT framework. It is basically what they call infrastructure as code. The deployment typically takes about 30 minutes. Within that time, maybe less. Within that time, the connectivity between AWS and Snowflake is established. And once you run your first TDT Lambda, TDT creates the required resources in Snowflake, and then you can send off your bulk load and CDC processing. Earlier, we talked about the Delta tables and views. Here you can see where those resources fit into the overall architecture. One of the first things TDT does when new data comes in from the mainframe is to automatically create all the Snowflake resources required for the data transfer. Looking through the metadata, creating structures where it can land. That includes the schemas, the stages, the file formats, which are proprietary to Snowflake. And then you have those Delta tables we talked about and the various views. It creates JSON views and user views. The JSON views are just the data in JSON format in case you want to do some pandas or PySpark manipulations with it. And then you have your user views, which are relational alike. So if you want a view of your mainframe as it looks like on your mainframe, you'd want to utilize that kind of view. The customer never creates anything in the target manually. At least they don't need to. You can leverage it as it is. Of course you can, but TDT provides and runs the scripts automatically, eliminating the possibility for human error when you're creating everything, for example, in a bulk load. So you're doing a large bulk load into Snowflake. TDT creates automatically all the target creation and then the load, which is why you're using it in the first place. As data begins flowing from the mainframe, TDT populates the delta tables and then continually accumulates the history of all the inserts, the updates, the deletes over time. On top of these delta tables, the views are created as we had discussed. Now, at this point, we've talked about what TDT does and how it does it. Now let's talk about why deploying TDT on AWS provides so much value for our customers. First of all, customers get a full pre-configured framework that can be deployed in their own AWS environment in about 30 minutes. Great. Not only is this secure, but data is not leaving their territory. And second, the whole approach is inherently immutable because Lambda layers themselves are inherently immutable. They're versioned and it prevents anyone from changing the code of the application in any way. Instead of spending months designing infrastructure, provisioning services, writing code, building and deploying processes, the customer or anyone is able to start with a framework that's already built and tested. Another major advantage is scalability. Because TDT is built on managed AWS services, the platform can scale as data volumes grow without customers having to redesign the architecture. The solution is also highly available by design. There are no application servers for customers to maintain, patch, monitor, or replace. Data is also protected through the process. TDT also leverages S3 for durable storage and backup, providing that additional layer of protection throughout your pipeline. From a cost perspective, customers benefit from AWS's pay-as-you-go model. So you're only paying for the resources you're consuming rather than maintaining infrastructure that is sitting idly most of the time. And finally, customers don't need to become experts in every AWS service used by the framework. TDT abstracts away much of that complexity while still following AWS best practices underneath. The result is a solution that is fast to deploy, easy to operate, highly scalable, and ready to support future growth without requiring customers to continuously reinvent the architecture every couple of years. At the end of the day, none of the architecture matters unless it delivers results, right? So for this auto manufacturer, the outcome was fully automated, a fully automated solution capable of continuously moving data from the mainframe into Snowflake in that near real time. Today, CDC events are propagated continuously, giving their business access to much fresher data than they had before. On the bulk load side, we're talking about moving terabytes of mainframe data into Snowflake in a matter of hours. To give you a perspective of something smaller, how long it would take, we can see an example transfer of this popularly known mouse genome database. This is just a sample database with 375 million rows, 170 tables, 66 gigabytes. The transfer to Snowflake from mainframe all the way to the end is an under 5-minute transfer. Now, this transfer will vary in time because you do have those two components. You have the TDT component, but before that, you have that mainframe data replication tool. And what we've seen with our stress testing is that usually the mainframe data replication tool is the one that's the bottleneck. So depending on what tool you choose, how fast it is, TDT usually runs much faster than that first bit. So it is how you make it. Could it be made even faster? This whole thing? Absolutely. If a customer wanted to spin up a larger Snowflake warehouse, increase concurrency thresholds there, or also in AWS, and allocate more resources across the entire environment, they could drive the latency down even further. But doing that comes at a cost. One of the things we like about this architecture is that the customers are able to fine tune and balance everything themselves. Every organization has different requirements. Some businesses need data available within seconds. Others are perfectly happy with minutes or hours if it means significantly lower operating costs. And the framework gives customers the flexibility to choose where they want to sit on that spectrum of cost. So for our customer, the current configuration provided, like the default one and with slight tweaks, provided the right balance between performance and cost. They were happy with getting their huge bulk loads there in several hours. Beyond performance, they gained capabilities they simply didn't have before. History accumulation became automatic. Mainframe hierarchies were preserved in the target. We'll talk about the hierarchies in our demo. The architecture could scale as data volumes continued to grow without requiring the redesign. Now, on the business side, they were avoiding those months and years of engineering and custom framework configuration. Keep in mind, they had already lost some time trying to engineer it themselves. They accelerated their entire modernization initiative, gave the business users full access to the data, and established a foundation for future analytics, AI, and machine learning because everything was already in Snowflake. Most importantly, they now have a repeatable framework that can continue evolving as their business grows. And hey, if you want to ditch Snowflake and go target a different analytics platform next year, that switch can be a seamless transition because AWS is an intermediary in the whole thing. They could just point TDT in a new direction. The auto manufacturer in today's case study happened to be working with Database, vSAM, and DB2. However, TDT supports a wide range of other mainframe technologies, including IMS, IDMS, Datacom, flat files, and several others. Other TDT flavors are designed to source from non-mainframe sources as well. We're not going to get into those today. And the targets list is not just Snowflake. You can go to Amazon Redshift, Amazon Athena, RDS, even Bedrock SageMaker. This is to give you some more perspective. Now let's go on to a little demo. We're not going to be doing a full-on demo because again, that CloudFormation template takes 30 minutes to run to spin up everything. But we will be looking at bits and pieces. So let's take a look here at an example with an database file. So if any of you are familiar with, there is this sample database file. It's the employees file. It looks like this. It's just employees, name, job, phone, all this stuff. And then there are child and grandchild tables within that employees table. And let's switch over to the AWS console and see what that looks like in our AWS environment and in Snowflake. Let's see here if I'll be able to switch. Here we go. All right, so if you recall, we spin up the TDT environment with a CloudFormation stack. Now, I have my stack opened up here. This is an empty stack that I have to fill out based on the TDT. So I'm going to give it a stack name. We're going to call it our demo stack, for example. Then you can put in a prefix. So we're just going to call everything. We're going to put a prefix on all of our resources with demo. We can provide the MSK cluster ARN. This is for your Kafka connection. We're going to leave this blank. We can fill it out later. You provide your Snowflake account identifier, your Snowflake username. Here I'll put Elisavova for mine. My password, the Snowflake database. We're going to put it in a database called demo. All of our data from the mainframe is going to go. This is the Snowflake database. And the Snowflake integration is optional. We can fill this out later. And then TDT will provide the 2 Lambda layers that are required for this. I'm going to click next. I acknowledge, next. And then I'd have to click submit. Now, we're not going to actually click submit because it's going to take 30 minutes, but I'm going to switch over here to show you how I already ran it. And here it's complete. It created all of these resources. We're not going to go through them right now, but everything is created. One of these resources is there are many lambdas, but this is just one of the lambdas. And instead of feeding from the mainframe itself, I have just captured an event from the mainframe. So this is the event JSON that gets fed into the Kafka topic. So this is AWS Kafka. And this is just, it's not meant to be looked at in detail, but this is our event that's going to be going through our Lambda. Now, when the data comes in from the mainframe, it gets landed in our S3 bucket, right? it gets landed right here. This is our employees file landed in these compressed gzips. This is that data working storage layer. Then once the data comes in, it's going to get pushed into Snowflake. Before that, TDT will create the target resources. Now let's look at our target resources. If we go to our databases, remember we created a demo database in Snowflake. Since AWS doesn't have schemas, it's going to default to put it in the public schema. You can configure this later to put it into whatever you want, but I'm just, for the sake of the demo, we're just going to put it in the public schema. And TDT has created a table, the employees delta table, and all the views. I hope this rings some bells. We have the employees view, employee income bonus. If we look again, these are those different tables within employees. They're all separate views. Now, the very nice thing is that you see these hierarchies here as they are in the mainframe. TDT preserves these source hierarchies. It does not normalize or flatten these tables in Snowflake. And it's one of the greatest added benefits of TDT. Now let's take a look at what something on in the delta table looks like. Let's select the delta table. So the delta table is basically JSON as it's coming in from Kafka, from the mainframe through Kafka in and inside. You can see that the action here is an I. So this is an insert, meaning all these are I's here. So if this was changed data capture, it could have been a update or a delete or an insert, but since we're doing a bulk load of this employees file, everything here is an I. And on top of this delta table are the views. Let's check out one of the relational views, the employees view. So here you go. You can see everything in Snowflake as it is, relational style, first name, middle name, everything, all these fields are here with some extra timestamps. And now let's look at one of the grandchild views. So let's take a look at one of this grandchild view, employees income bonus. Let's select that one and see what we get. So for this view, notice that we have these two columns, income index and bonus index. This is meant for, these are hierarchy preservation indexes, which are meant to maintain the original database parent-child-grandchild relationships without flattening that structure. So having this here is very valuable when your trend analytics and business people are trying to piece everything together to get that hierarchy again. And then we have those JSON views, if anyone wants to utilize those. They're not relational, they're JSON again. But if you're using Pandas or PySpark in Snowflake in one of the notebooks or in your workspaces, then using these JSON views might be beneficial. And as I said before, you can create more views. You can tweak the ones that we've created or just copy and make different ones, which is what our auto manufacturer did. They're using these, but also have their own. Now let's go back to our deck real quick. Here we go, back to our deck. It should load in a second. Here we are. Sorry for that wait. We showed you our demo example. Let's just wrap everything up and talk about our takeaways. If there's one thing I'd like you to remember, it's that a successful data modernization isn't just about moving data. It's about using a framework that can scale and adapt to the environment. Data centralization is key to an efficient business. Historical data retention enables analytics, and together they create a foundation for future innovation. And that's exactly what TDT helps organizations achieve, transforming mainframe data into a strategically utilized asset. Thank you for joining us today. If you'd like to learn more about TDT or discuss your own modernization initiatives, I encourage you to reach out to us directly. Feel free to email Joe. His email is here, jbrady@treehouse.com. And my team and I will look forward to hearing from you about your modernization initiatives. Also, if you'll be attending the AWS Summit in Washington, D.C. on June 30th and July 1st, it's a 2-day event. It's free. Be sure to stop by and say hello. I'll be there. I think Sunil will also be there. The summit should be really fun. Feel free to shoot me an email as well if you're planning on going. My email is here as well. Treehouse, thanks you for watching, and we'd be happy to take any questions about anything we covered so far.
Wonderful.
So let's look at the questions that came in.
Do you see some questions that have not been answered? I'm scrolling just to find some.
Yeah, and I invite Dan and Joe to also join in as they've been in the chat this whole time. Anything that stuck out to you we should address first?
Sure, I know.
I see there are few questions. We just posted like 10 minutes back, 5 minutes back. How does it handle the code units data? Is there any way we can try or practice this process? Maybe a workshop or something. I think that's what the participants are expecting.
Yeah, Joe, do you want to take, is there any way we can try or practice this process? You want to take it, Joe?
Well, we can, if you're talking about having a POC or a demo, the potential customer can contact me or Ellie, and we could set up a session for you, a more detailed, personalized session for addressing your project's needs.
Yeah, we are going to share the slides and also the recording and the contact details for all the participants who has joined and registered. So feel free to reach the Treehouse team, and they are happy to help you in the opportunities.
Yeah. Just to elaborate a little bit on what Joe said, what we would love to do, one of the nicest kind of ways of getting you familiar with TDT is by using your data. So if you have it available to you, an AWS Sandbox account and a Snowflake Sandbox account, and basically we could, doing a quick getting started guide kind of approach using your data is usually the best way to go about it. We can provide sample data, of course, the AdventureWorks database, things like that to play with. So that's the absolute quickest way. But the nicest way is to do a POC using your data. It makes it much more graspable, and you can show it to those end users who will be utilizing it ultimately in Snowflake to let them know what, let them get their hands on it and play with it.
Yeah, we also have a question. Is there any demo of the source setup in the mainframe? We could facilitate a demo to show you the mainframe. Every customer will have different tools, different mainframe data replication tools. So we could set up a demo with with Rocket's RDRS tool that works in conjunction with TDT and show you that whole flow. As we said, it's a substitutable component. We're only showing you the downstream in today's video, and it would take a little more to go through the whole demo and explain everything. But we could absolutely set up a session and talk through it. Yes.
And I see some really kind of standard staple kind of questions. Is data encrypted in flight and at rest? Great question. And if anybody like us said no, then you would want to run away as fast as you can. So yes, everything is of course encrypted in flight and at rest, and especially when we're utilizing the intermediate components that are in AWS. We simply utilize all the best practices, KMS kind of approaches to securing the data in S3, for example, or in flight. It's all encrypted all the way, just all the standard bells and whistles.
Yeah, I guess we should have added that into our. I think it was obvious that of course it's encrypted.
Yeah. And another big thing for mainframe users, they're accustomed to, throughout the last few decades, having trouble with converting code sets, going from Epsidic or the other kind of funky internal storage on the mainframe and converting that into well, for our cases, Unicode. That's generically speaking, that's handled by the mainframe data extraction tool. In the most common case, that's Rocket's RDRS. They handle the Epsidic or the other formats. Those funky packed numeric formats, they handle that, turn it all into nice fresh Unicode and send it into Kafka. So everything that TDT is consuming is just standard JSON in Unicode format.
Correct.
Eddie, can you bring back the slide? Just we can cover the next topic we have in 2 weeks.
Oh, yes. Here we are.
If you don't mind. So thanks for all the people that are still there. So in June 33, we're going to present the new announcement we made 2 weeks ago about the MCP server for AWS Transform for Mainframe. So until now, you had to go to the AWS console to have access to the tool. Now we try to bring the tool where the customer is, which means you can be using your CLI, you can be using probably Kiro IDE, you are maybe having your own SaaS solution to do orchestration with different agents. And now with the extension of Transform with the MCP server, you can bring all the agents of AWS where you are. So that's going to be the topic to present this new announcement we made, plus a demo to show you how to configure it and how to use it. And I think we have covered most of the questions.
Actually, there is one really good question.
Oh, please take it.
Yeah, really good question. Thank you for asking it. Asking about bidirectional data transfer. And we Treehouse, we do have a number of our customers who are doing bidirectional transfers. This case study was on obviously the case study going from the mainframe to an analytics platform like Snowflake, which tends to be like a one-way trip because there's not transactional processing, generally speaking, happening in Snowflake. Our customers that are doing bidirectional, they, for example, are going like Database, for example, or DB2, for example, on the mainframe, propagating to a relational database, potentially an RDS database in AWS. And we do have the means there, leveraging the Rocket technology to set up a bidirectional feed. Initially, generally speaking, starting mainframe to target RDBMS, but then setting it up to where transactions, inserts, updates, and deletes on the target RDBMS can be cycled back to the mainframe. So that's quite a common thing, but it was outside of the scope of this presentation. But if that's your thing and that's your interest, talk to us. Shoot Joe a note, and we will get with you on that as well.
Yeah, if you want, Dan, I can pull up the slide with all of our sources and targets. If you want to see that one more time.
And we're going to put the slide and the recording in the box folder. For anyone who still not have access to the folder, please reach out, reply to the email you receive with the invite, and we're going to make sure that you're part of this box folder with the link. Some of the company did not allow box as a common share folder that I can use. So you have to register with your personal email address, and then I can add you. That's one of the issue we had with some of the company email restriction policy.
Yeah, and yeah. Also, if you just email us, we'll also send it the deck and everything. Any other questions? Let's see.
Yeah, I'll just throw out a question that a lot of people ask that I didn't see asked here is about cost reduction, cost maintenance, keeping an eye on the dollars. Because when you're pumping like petabytes of data through, you're going to be generating some billing, both from AWS and Snowflake, and everyone has an interest in minimizing that. And I'll just say we on the cloud team at Treehouse are really constantly surveying the horizon for new offerings in AWS or new offerings in Snowflake that allow us to reduce the cost. And so I'm not going to go into those now, but when we do a POC with you, I'd be happy to share some of those. We have come across over the last few months some enhancements that we've made to reduce billings both on the AWS side and on the Snowflake side by taking advantage of some of the new offerings, the new detailed offerings that AWS and Snowflake make available to help with that. That's always on our radar, and that's part of the advantage of subscribing to our stuff, is because we are always keeping an eye on that for you, and we're taking in input from our various customers and putting that all into what's available in the frameworks that we offer. Cost is a biggie. Security is a biggie. Those are the things that we focus so much on, not just making sure that it is 100% reliable. And another question came up about points of failure. And those are a huge issue to us, the various points of failure that might come up, even those the really far out things like an S3 bucket becoming unavailable. How far out is that? But in some cases where you're really sensitive to that, you want to be able to even deal with the failure of an S3 bucket. Like, what is it? 11 nines reliability? How could that ever go wrong? Well,
Yeah.
it's 11 nines. It's not, infinite nines. So always keeping an eye on those things.
Yeah, and we align closely. We try to build everything around those 6 pillars, the well-architected framework, for those of you that are familiar with it, as is best practices. And we always encourage our customers with their implementation of TDT to move their surrounding components of the architecture in a best practices direction. For example, transfer the data over before you transform it, land it, use that S3 intermediary zone, take advantage of our archiving capabilities. There were more features of TDT I didn't have time to cover, but one of them is archiving. We support that out of the box. Since you're already going through AWS into Snowflake or whatever target, TDT can optionally keep an archive in S3 at a very low cost in Glacier. But that's something you can learn more about in your next session with us.
Yeah, and cost management in Snowflake. We also provide those delta tables. We also automatically provide, it comes along with what we generate, delta archive files. So because those delta tables, if you're pumping deltas into that for years, they can get huge, and it's usually advisable to archive some of the older records off into separate archive tables, so that when you're then manipulating data in the more current delta table, it's a lot less expensive. That's part of cost reduction, making it more manageable and reducing the costs.
And the other point that we can make is, and this ties into what you were talking about, the cost management, and several of the questions sort of alluded to this, is the idea of future proofing. We use that a lot, the statement in Ellie's presentation. And would you, Dan or Ellie, elaborate more on the future proofing that TDT, a subscription to TDT, provides? You can elaborate on on how that, how we constantly track what's going on out there, and how TDT can adapt in the future for things that we can't even imagine yet.
So let me just elaborate. So TDT is built in a decoupled fashion. All the components are substitutable. Just from the very start, you can have that mainframe data replication tool. Any tool can plug in there. Any data streaming platform can plug in there. Downstream, it's also like that. So let's say you're going to Snowflake today, you want to go somewhere else. You're not vendor locked into one solution. You can go to almost anywhere. If there's a new offering out there, Treehouse will be on it for sure. We try to stay current, and we will try to make support the new platform. Let's say the new thing is, I don't know, whatever it is. For example, when we learned about Iceberg, we immediately created support for Iceberg tables. Remember that hype wave? We try to stay current. We try to stay future proof in that sense. Good.
Yeah, S3, another S3 directory buckets. A few.
That was 2023, Dan. Yeah.
Okay, yeah. I was trying to remember. A
Yeah.
few years ago, they were announced at the annual convention of AWS, the reInvent, and within 3 weeks after we became familiar with them, we put in support for directory buckets. So and that was instantly available to our customer base. So that's the kind of thing we're always. I haven't yet watched the Snowflake presentation, the Snowflake big presentation from, I think it was last night. I haven't looked at it yet. They might have announced some new stuff that
That's on my
we're
homework
going to
to do.
latch onto immediately and put into
Yeah.
as much as we can, make it available for our customers to leverage.
Oh, great. Thank you.
Yeah, thank you,
Excellent.
everyone.
Once the webinar is over, like a survey link, a survey screen is going to come on, flash on the screen. So please feel free to fill your survey. And also we are asking for the recommendations for the upcoming sessions. So please post if you have any specific interest. We are going to take it and consider it based upon the number of upvotes we have.
Thanks, everyone. And see you in June 23.
Bye.
Thank you all. Bye.
Thank you.